Guys, this is Leander here. I have a problem with this question and I was wondering if you could help me with it.
Alrighty, so congrats on that TV, Leander. We will be in touch with you as to how you can get your prize. But for now, we're going to look at your question. As you can see, guys, it's a functions question. It's got nothing to do with similarity and proportion. That is the beauty of the wildcard question. Anything you're struggling with, send it through and we will have a look at it. So let's check this question out. It says, given that h of x is equal to a multiplied by 2 to the power of x minus 1 plus q. Okay, so that's what this graph is over here. The line y equals 6 is an asymptote of h. Okay, that is very important. Okay, because remember, in your exponential function, which is what this function is, that q value is always given to us as the horizontal asymptote because this expression can never equal 0. 2 to the power of anything will never equal 0. Okay, so with this exponential function, because this can never equal 0, it will never touch this line y equals q. Okay, so this horizontal asymptote of y equals negative 6 gives us our q value. That asymptote is very important. Secondly, it says p is the y-intercept. Okay, so that will probably be, we've labeled it incorrectly here. It's meant to be p over here. And t is the x-intercept of h, so that's this intercept over here. Okay, firstly it says write down the value of q. Well, as I mentioned before, because this expression can never equal 0, h will never touch this value of q. And because it will never touch it, it's the asymptote there, so q is equal to negative 6. Okay. Secondly, it says if the graph of h passes through the point -1 and -5¼ calculate the value of a. Okay, so now remember we've established that h of x is equal to a, we don't know yet, multiplied by 2 to the power of x minus 1 minus 6. That was that q value over there. Okay, so easy stuff here. We just substitute these values into that equation and we can solve for a. So h of x represents the y value. So we have -5¼ is equal to that unknown a multiplied by 2. Okay, so x is -1 over here. So we have -1 minus another 1 because it's x minus 1 minus 6. Okay, so let's keep working with this. If we change this into an improper fraction, -5 multiplied by 4 is -20. Minus 1 is -21 over 4. A multiplied by, well, we're going to get 2 to the power of -2 because remember, -1 minus 1 gives us -2. So 2 to the power of -2 is 4, but it goes in the denominator because remember, a to the -1 is equal to 1 over a. Just a side note over there. And, well, we've already got two fractions with a denominator of 4, so we might as well convert this -6 into a fraction with denominator of 4, so we get 24 over 4. Now we just have to isolate a, so we get a over 4 is equal to, well, if we take this to the other side, we get -21 over 4 plus 24 over 4, that gives us 3 over 4. And that's easy peasy, equal denominators, so it must be equal numerators. Therefore, a is equal to 3. Simple stuff. Okay, now, before we forget, we've established h of x is equal to 3 multiplied by 2 to the power of x minus 1 minus 6. Okay, and that is this exponential function here. Thirdly, it says calculate the average gradient between the x-intercept and the y-intercept of h. So firstly, we need to find those intercepts. So for the x-intercept, we make y equal to 0. So that simply means that 0 is equal to 3 multiplied by 2 to the power of x minus 1 minus 6. Okay? That means that 3 multiplied by 2 to the power of x minus 1 is equal to positive 6 if we take this 6 to the other side of the equality. And now if we divide both sides by 3, we get 2 to the power of x minus 1 is equal to 6 divided by 3, which is 2. Okay, so now easy peasy stuff. Because we have the same base, we can equate the exponents. Remember, there's an imaginary 1 on any normal number there. So that means that x minus 1 not equal 1. X minus 1 is equal to 1, which means that x is equal to 2. So the x-intercept is 2 and 0. Now, to find the y-intercept, we make x equal to 0. So we get y is equal to 3 multiplied by 2 to the power of 0 minus 1 minus 6. That means that y is equal to 3 multiplied by 2 to the power of negative 1. So that's 3 over 2. Remember, 2 to the power of negative 1 is 1 over 2. So we get 3 over 2 minus, well, we might as well put that 6 over a denominator of 2. So we get 12 over 2, which means that y is equal to negative 9 over 2, which means that that y-intercept sits at 0 and negative 9 over 2. Now, all we've done is find the intercepts. Remember, the question said find the average gradient between the intercepts. So remember, gradient is equal to change in y over change in x. That's going to give us negative 9 over 2 minus 0, because y minus y, all over the first x value, which is 0, minus the second x value, which is 2. Okay, so we get negative 9 over 2 minus 0 is just negative 9 over 2, and 0 minus 2 is negative 2. Okay, so if we divide a negative by a negative, we get a positive, so those two negatives cancel each other out. 9 over 2 divided by 2 is basically saying 9 over 2 multiplied by a half, okay? Easier way to express that situation, which gives us 9 over 4. And that is the average gradient. If we were to join these intercepts here, this is meant to be P, we would get that line there. The gradient over there is 9 over 4. And that makes sense because it is a positive gradient. It's going positive. And it is quite small. It's got a very sort of like non-steep gradient of that line.